This is the Trebco personal intranet. We're going to be looking at some of the features that I came up with in 1990, 1991. This is Professor Raymond Buck. We're going to be looking at the math features of the Trebco Tablet that I came up with. This is Trebco Computer Systems. I'm Professor Raymond Buck, Research Professor Raymond Buck, and we're going to be looking at some of the systems. Today we're going to be looking at the math function. It can be used in the Trebco Education Tablet, the Trebco Engineering Tablet. They tried to stop my technology from coming out. Apple stole my copyright. Microsoft, Samsung, Highway, Exomi. It's amazing when someone steals from you that they don't know how to use the technology. So all you see is them punching on a cell phone or tablet, but they can't show you how things are done. I got a question for you guys. We're going to look at one function. We're going to look at item number 16. Y is equal to the sine x cubed. Y is equal to number 16. Y is equal to the sine of x cubed. What does that look like? Okay. That's y is equal to the sine of x cubed. Now, my question is, and this is the reason why they should have given me employment, and they didn't, because the students are going to be confused. Now we're going to look at y is equal to the sine, number 17, the sine of x cubed. Is that the same as y is equal to the sine of x cubed? Are they the same? Those two. This one and this one. Well, let's see. You know, I couldn't find a job. They stole my tablet and I couldn't find a job. Tried to act like I was, didn't know what I was doing. It really, really hurt me. Once again, this is the Trebco Tablet using the Trebco personal intranet. This is the mathematical curve plotting function that I invented for students. And for some reason, they want the kids to use videos on YouTube. And so if I was putting in a bunch of videos and funny stuff on the internet, I would have 40 million hits. Okay, well now we're going to go back to y is equal to the sine of x, quantity cubed. Is that the same as y is equal to the sine of x cubed? Go number 16 first again. Y is equal to the sine of x cubed versus number 17. Y is equal to the sine of x cubed. They're not the same. So when your mathematical professor, high school, college, grad school, wouldn't give you credit, they couldn't give you credit because the two quantities are not the same. They're not the same. My software should be in every school. I'm Professor Raymond Buck. We're going to continue with some other functions. We're going to look at, I guess we're going to look at number 1, electrical circuit analysis. So let's go with Kirchhoff's current law. Once again, I'm Professor Raymond Buck. Today we're going to be looking at Kirchhoff's current law. This is part of the Trebco Tablet featuring the Trebco personal intranet, and of course, we can't forget the Trebco Coderian matrix. Today we're going to look at two resistive elements. You got a voltage supply, you got a resistor R1, resistor R2, and a voltage supply. So let's say R1 is 10 ohms. Excuse me, 10 ohms. And we want the R2, let's make it 20 ohms. And of course, our voltage supply, we're going to go with 120 volts. See what we have. Voila. Let's see how easy it is to try another one. This is the Trebco personal intranet. I'm using the Trebco tablet and of course our powerful Coderian matrix technology that I'll never tell anybody since they stole from me. I'll never tell anybody. Oops. Made a mistake. You got to put voltages in. Now, resistor 1, R1 is 1 ohm. Resistor 2 is 2 ohms. And the voltage supply is 120 volts. There we go. I wrote this software, like I said, in 1991. Started doing the equations in 1981. And of course, I made the notes in 1974 when I had an electronics kit from Radio Shack. And that's where my initial circuits that I was working on. So we just already done the y to delta, and now we're going to do the delta to y. We're going to do it in reverse of what we just saw. Okay, so if I did this correctly, R1 was 3.666666, and the other value. There you go. We're going to be looking for x, y, and the missing number is going to be z. And I'm going to use something really simplistic. Oops. Okay, sorry, I hit the wrong finger. We're going to do 1, 2. We already know what the next number is going to be. So we're going to say 4, 5, and 6. So what numbers are we missing? We got 1, 2, 4, 5, 6. What number are we looking for? Huh?